Class, we will start today's lecture with a recap of the periodic table. So this is how your periodic table looks like. If you remember yesterday's lesson, we have here the zigzag border, which separates the non-metals from the metals. So let me repeat that. You have the zigzag border, which separates the non-metals from the metals. And on the zigzag border, we have the metalloids. Today's lecture will focus on the nonmetals as we discuss the formation of cations. Formation of ions. Let's start by defining ions. Ions are electrically charged particles. That means they are either positively charged or negatively charged. Now, the positive ions, we call them cations. Negatively charged ions, we call them anions. Now, to help you remember, notice the T in cations. That should make you remember that they are positively charged ions, and the N here in anions should make you remember that they are negative ions. Now, compare this class to your atom. So we said the atom is electrically neutral. And what was the reason we gave for that? It's because the number of protons is equal to the number of electrons. So now, when we're talking of ions, this is no longer an equality. And if we are looking at cations, this means now that the number of protons is greater than the number of electrons. And if we are talking of anions, this means that the number of electrons is now greater than the number of protons. Okay? So can you just remember cations, positive ions, number of protons greater than number of electrons. Anions, negative ions, number of electrons is greater than number of protons. Okay. Now, why is it that there is a losing or a gaining of electrons in atoms? We can explain that by way of the octet rule or the rule of 8. Okay, this rule tells us that an atom tends to lose, gain, or share electrons in order to have 8 electrons in its outermost energy shell. Now, why 8 electrons? This is attributed to a stable configuration, which is similar to that of the noble gases. Now, if you notice noble gases like neon with 10 electrons, its electronic configuration is 1s2, 2s2, 2p6. So it has 8 electrons in its outermost energy shell. And that makes neon very stable. Of course, there is an exception among the noble gases, and that will be helium, which can have a maximum of 2 electrons in its outermost energy shell. So just to repeat, all atoms will want to be stable. That means they will want to have 8 electrons in their outermost energy shell. And how will they do that? They will either lose, gain, or share electrons. Okay, so today we will look at how the atoms will lose the electrons to become cations. All right. So, cations, the number of protons will be greater than the number of electrons. And how will this happen? The atom will be losing an electron or several electrons for that matter. So, cations are formed when atoms lose electrons, and the atoms that tend to lose electrons are the metals. Why? Because it's easy for the metals to give up their few valence electrons. Now, class, you will have to notice here or to remember that the number of electrons lost is equal to the charge of the ion. Okay? For example, if sodium atom loses 1 electron, it becomes a sodium ion, and its charge will be positive 1. Okay, we will look at this structure of sodium in more detail. All right, sodium has 11 protons 11 electrons. And since it has a nucleon number of 23, it has 12 neutrons. Its electronic configuration is 1s2, 2s2, 2p6, 2s1. Notice that sodium has only one valence electron. So how can it become stable? All it needs to do is lose this one valence electron. So if we were to draw the sodium atom, okay, so we will have its nucleus with 11 protons, 12 neutrons, right? And we have 3 electron shells. The first shell will have 2 electrons, right? The next shell will have 8 electrons, right? That's coming from your 2 plus 6. And the third shell will have 1 electron. So how can the sodium atom become stable? It will lose this 1 electron, this 1 valence electron, and so it will become this structure. Right? So you will still have your nucleus, you will still have your 11 protons here and your 12 neutrons, but now notice that since the atom is losing the valence electron, now it will only have 2 electron shells, right? In the first shell, we will still have the 2 electrons. The second shell, we will have the 8 electrons, right? But since sodium is now an ion, we will have to draw it like this. We'll put in this bracket with the positive charge, okay? Why positive? Notice the number of protons is now equal to 11, but the number of electrons is equal to 10. So if we were to look at the net charge of sodium, you will have 11 times plus 1, you have 10 times negative 1, so it will have a net charge of plus 1. Right? So sodium atom, and this is your sodium ion. Okay. I will pause here and let us look at more examples.